This is Pan. Today we'll be doing a complete cell replacement on a Ryobi 12 volt CB120L lithium ion cordless. Begin by turning over the battery housing and removing the first 4 screws from the bottom of the housing. You will need a T9 Torx screwdriver to do such. Remove the screws by inserting the screwdriver into each individual screw hole and turning in a left or counterclockwise motion. This film was produced in its entirety for the beginner, so if you are an advanced repairman, you may fast forward through the parts that you are familiar with in order to proceed to a position where you may need guidance in. Be sure to have a pair of safety glasses handy for the next step coming up. Once all 4 screws are removed, hold the top of the battery housing, which you stick into the drill, and slightly jiggle upward. Grab onto the terminal base inside and slightly jiggle the batteries out of the bottom of the battery base's internal housing. Set the screws inside the internal housing for safekeeping and use at a later time when we reassemble. At this point, you'll want to have your safety goggles on to make sure that you do not get shot in the eye with something if you happen to short out the terminals as you're scraping off this foam rubber. As you can see, while I am scraping off the foam, I am sticking to the center of the battery in order to not short in between 2 of the terminals. Make sure you clean off all the foam and glue off these terminal tabs, as later any residue left behind will cause a problem for our soldering portion of this repair. You will see these 4 divots in each battery itself. There's a total of 3 batteries containing 4 divots in each battery. These will be drilled out later. Flip over the battery to the opposite side and proceed to remove the foam from this side as you did with the previous side in the same manner, but still wearing your safety glasses. Oh yeah, make sure you're wearing the glasses for this next part here. We're going to proceed to drilling each individual cell's 4 divots per cell. For a total of 24 divots, we'll draw 2 complete, taking out these 3 dead cells from this pack. See, I wasn't joshing. I got mine. You wearing yours? Proceeding with drilling out the first cell's tabs. Hold the circuit board upward. Since gravity falls down, you do not want metal shavings falling onto the circuit board as you're drilling. Continue drilling each individual tab's 4 divots until you have the tabs busted loose from the battery and still connected to the circuit board. Very easy pressure is only needed. You do not want to drill all the way into the battery. Periodically check the tab to see that it is loose from the battery. At this point, stop drilling. Moving on to the second cell's 4 divoted connections on the tab. Clean off the excess shavings from your drill bit. Now I'm checking to see if the tab itself is disconnected from the battery so I can stop drilling. See how it freely moves loosely off the face of the battery? That means it's done. Moving on to drilling out the third tab's 4 divoted connection on the third battery. You will want to continue checking these tabs periodically on each cell that you're drilling. No longer connected to the battery itself. This is how you know you don't need to drill any longer. Okay, this is the last cell to drill on this side. I can see that it's loose, so I'm going to start slowly moving the tabs outward and upward so that I can pull the battery retainer, which is that black plastic piece, slowly down once I get the other side drilled out, and then just slip the batteries out without ever messing with the circuit board itself and the connections on the circuit board. Just as we did on the first side, we're going to continue to drill these out on the second side. As you can see, I got that done. I kind of give you a little bit of a lapse time here, and because you know we did the first time, so I didn't want to make you watch all that drilling again. Very gently take a knife and peel this tape off of this resistor here, but make sure you don't pull too hard to pull the resistor off of the solder connection on the board. Just be very gentle with the tape as you take it off. Okay, now using the number 1 Phillips, you're going to slowly remove these 4 screws on the top of the board. I like to use my battery housing encasement to hold my screws because it's like a free little cup waiting there, you know. You don't have to go grab nothing extra. Okay, these DC battery packs work in series, which isn't too complicated. It's a combined total of all the batteries put together, which would be negative to positive, and positive to negative in this battery's case. An easier way to do this is to just pre-place them. Negative to negative, positive to positive, and negative to negative. In the order of which I'm going to take them out, I will replace them. While supporting the bottom detainer and circuit board with one hand, slowly start removing and replacing the batteries in the order you have them laid out, one at a time. Once the new batteries are in the old battery's place, take the detainer you removed, replace it underneath the tabs, and slowly push the tabs down back towards the battery. There is a little notch in the detainer here that's tight. You just use a screwdriver to push it down tight up against the battery's face. The same thing with this bigger tab that connects the negative and the positive here. Right where it goes into the detainer, there's a little clip that kind of puts pressure on it. So just make sure it's pushed all the way to it as much as you can. When we solder that, we'll get it pushed all the way up here. We're just about done. And I'll go back to your number 1 Phillips and reinsert the 4 screws in the circuit board, securing the detainer and the batteries to the circuit board. Now you can dispose of the old cells or choose to test them later and recharge them. Some may be good, others won't be. Everything looks good here. It's time to move on to the soldering portion of our repair video. Let me just real quick get these tabs pushed in for the second battery pack I'm redoing too at the same time. If you need a little more help with the soldering portion of the video, I'm going to leave the second soldering of the battery to the end of the video in case you need a little more help with that. You're going to need electrical solder and any standard 30 amp soldering iron will work. Safety glasses, of course, you're going to need those. Now let me duly note that electrical solder and plumbing solder are 2 different types of solder. Electrical solder has flux in it, plumbing solder does not. Besides the obvious size difference, for some reason I feel there's a joke here to be made that I cannot say. Now I did do some editing to shorten my video a bit. I have to say, when you solder, you must first make sure you preheat the material up that you are soldering prior to putting the solder to it. Both the tab and the battery itself must be heated to approximately the same temperature to accept the solder. Do not melt the solder on the soldering gun. You want to melt it on the tab and the battery itself. Preheating the tab and the battery to the correct temperature is a lengthy process. It does take some time. If you touch the solder to the tab and it does not melt, you need to continue heating. And then I'm using the screwdriver here to push the tab to the battery. When you push the tab to the battery, hold it with the screwdriver, and you will wait until see the solder will start to solidify. Once it solidifies, you can lift the screwdriver off and then just reapply. Okay, the first tab looks like it's starting to be pretty secure here. Once it stiffens here, I'm going to move on to battery tab number 2. I'd like to express to you that when you are soldering the positive side of the battery terminal is a lot smaller, so you're really going to have to make sure that it's more so in the center than the 4 holes. You will still cover the 4 holes, but you will see the tab slit on the positive there, so just put a little more heavy solder in the center, because that terminal on the positive side of that battery is a little bit smaller, and it's not as flat and wide as it is on the negative sides of the battery. You'll be able to get it to work. Just get it pretty thick on there, and just so it's not protruding too far past beyond the retainer clip itself. You don't want it really sticking out and pointy and stuff like that. Okay, it's actually stuck pretty good, but I would like to make it just a little bit thicker. So I'm not going to quite so heat up the tab as much. This time I'm just going to kind of melt the solder towards the top of the connection here and round it off, and then I'm just going to do the same thing by adding a little bit more to it, just so it's a little bit thicker right there, because that's that positive one I was telling you about. It's a little bit trickier. You don't want to heat it up too much though, because it'll bust loose from the battery itself. So again, while the solder's solidifying, I'm just holding the screwdriver down with pressure, pushing the tab towards the battery. I'll give you a little bit of inspection here. You can see, try to get all the loose stuff off. Make sure that nothing's going to hit the board. Pick all of it out. You see that little piece that came out of there? You don't want that bouncing around in there. So the second terminal is looking actually pretty good. I'm going to move on to number 3. This would be the last tab on this side of the battery. Just going to go through pretty much the same procedure here. Heat up the tab and the battery enough to accept the solder. Okay, I got that third tab on the first side of the first battery pack done, and I'm working on the next side of the battery. This side of the battery has 2 positives. I'm gonna try running some solder underneath the tab first to kind of help me through it. The process here might go a little easier, I'm thinking. Just trying to get that solder underneath that tab was a little bit more difficult than I anticipated. I'm going to heat the battery first and then apply the solder, bend the tabs back over to the battery, and then resolder the tops of them and be done with it. So I'm just going to hit all 3 of them right here once they take the solder, the battery. So I'm going in between the tab and the battery right now. The tab's lifted up. That was the negative. I'm pulling the tab up on this last positive one, and I'm going to heat up the solder and stick it in between it. Once I get it to stick, I'll just bend the tabs back down. Okay, I have the battery laying down and I'm applying solder to the top of the tabs prior to bending the tabs down into the solder that was priorly placed on the tops of the batteries themselves. I just work on putting solder on all three tops of all three tabs prior to pushing them down and reheating them and letting them solidify together. The soldering process does take a little time, so just be patient with it and keep working at it. You will get it. As long as you got your safety goggles on, you are not in any danger. But with a little time, you won't heal from. You only get one set of eyes, you know. Okay, these all look pretty good. I'm going to flip it up and start pressing the tab down into the battery, heating both the tab and the solder up on the battery at the same time, holding the tab down into the solder puddle with this screwdriver and let it solidify. I'm going to work my way through securing the 5th tab to the battery here by slowly heating up the tab and the solder that is placed on the battery itself by pushing the tab through the solder with the screwdriver in order to get it to secure itself. This will take a little while. Okay, now I'm going to just slightly heat up the solder that is on top of the tab and try to thicken the solder base that is on top so it's 100% on there and there's no possibility of it working itself loose, you know, because we do sometimes while we're working with our drills on a project have a tendency to drop the drill, stuff like that. I really don't find that the 12-volt cordless is a very good cordless for like screwing in screws and stuff like that. I pretty much use this 12-volt for drilling pilot holes so that I don't have to keep loosening and tightening the chuck, changing between an apex for the screwdriver and the drill bit for the pilot hole on the same drill. It becomes quite annoying. The 12-volt drill is pretty light, so it's pretty easy to carry both drills alongside or on your person while you're working. This one looks pretty good about now, so I'm going to work my way onto the 6th tab on the final battery of this battery pack. Just going to work the tab down here first. Remember, you got to push that one corner in pretty tight on the retainer there. And then just start, as you're pushing down with the screwdriver, melting the solder and the tab. You'd be basically pushing the tab through the solder just like before. You see how the screwdriver started to stick there? That's how you know it's actually hardened and just about time to finish it up. Okay, as you can see here, all 6 tabs are secured to the battery. Nothing is protruding past the retainer. Finish watching this video in its entirety. You may now want to go to part 2.